Hello, this is Ravi Mahadeokar. I'm a managing director of Summit Engineers and Consultants Private Limited. This company is engaged into manufacturing, design, manufacturing of adhesive coating machineries. Very recently, we have entered into manufacturing of PTFE coating machine applications. This is one of the unique and important kind of technology what we have brought into the market. Friends, today I'm going to talk about the dry film lubrication, a new approach for rubber O-rings and component coatings. Many of us are very much concerned about application of the coating onto the rubber components. Many times we do coat it with the dry film. Many times we apply the rubber powder onto the rubber components, and which is going to create some kind of temporary situation for retaining the components or the assembly of the components and all. But the new technologies or the technical things have come up in the market, which I'm going to talk to you hereafter. What do you mean by solid film lubricants? A solid film SFL, solid film lubricants are the dispersions of solid lubricants in solution of inorganic or organic resins or in solvents. The solvents could be water, it could be the organic solvents, or it could be water also. And after the application of this material on the surface and the following drying, this will get dried out, and a thin layer, it could be ranging from 4 microns to 20 microns, 25 microns of wear resistant lubricant coating is generated. And that is being taken care for your application, especially called as the solid film lubrications. The solid film lubrication would be possible to apply anywhere, everywhere. I've just taken an example of the industrial application, and that to be automotive application. However, it is not only restricted to the automotive or the engineering application, but also the food grade industries, as well as the pharmaceutical industries and the healthcare industry. This application is being utilized nowadays. This discussion, I'm going to keep it with reference to the automotive applications. The area could be suspension of bushings, cradle mounts, fuel lines, door locks and motor rolling, the belts, belt and related aspects, steering column hoods, wiper motor, and whatnot. Invariably, each and every component into the modern automotive applications can be coated with the dry film lubricants. The elastomer seals are the most preferred sector which has been utilized for the dry film lubrications, right? Why do seals have to be lubricated? If you really ask this question to yourself, you will start saying that, okay, probably I'm going to use it while application of the O-ring or the oil seals onto the shafts, I require to apply that. That is perfectly all right. But at the same time, there may be some another reasons actually. And this reason could be because of the geometry of the component as well as the fit or the typical fitment of the components onto the shaft. These are the two major parameters one has to decide for the lubrication aspects of it. The solid film lubricants, the major task is the dry lubrication. Obviously, the name itself is the solid film lubrication or the dry film lubrication. It has to reduce the friction and the wear. Lubrication under the extreme conditions, especially some of the components are getting exposed to the very big temperatures, or sometimes getting exposed for the chemical compositions or the corrosive atmosphere. So obviously this lubrication material, what we have been using it, that needs to be avoiding these extreme conditions. Of course, certain elastomers which are not which are very susceptible for the oils, or which are not good for the oils. And if I want to, if I come across the situation where I have been using those oil seals or the elastomeric material, and where it is going to get exposed for the oil, then I must have the better results. So another reason for the dry film lubrication is that for such kind of elastomers, I should be able to use this solid film lubricants for avoiding the oil resistance part of it. Then the running in optimization, the emergency lubrication in combination with the oil and greases, corrosion protection. Typically, the application could be what we have been talking about it is the brake fluid application, where the master cylinder or the wheel cylinders, which are being exposed for the different corrosive liquid or the corrosive chemicals. So the corrosion protection is another example into the automotive application. I'm not restricting the discussion or not asking you to restrict your thought process to this, but also wherever the corrosive atmosphere, it could be any type of corrosion, where we should be able to utilize this particular dry film lubricants. And of course, the noise reduction. These are some of the main tasks why one should be able to talk about the dry film lubricants to be applied for the components. As we have been talking about it, the automotive applications, uh, it's not only the elastomeric material, but also the plastic, engineering threads or the fasteners, which have been really utilized, really coated for the friction reduction. Okay. Again, here I will not be more focusing onto the metallic components and all. I'm restricting for the rubber because it is a rubber tech talk. Okay. So I would be more talking about the elastomers. Okay. Now, when I talk about it, it could be the belt, it could be the boot, bumpers, bushings, diaphragms, fasteners, foam grips, gaskets, n number of components, which probably I might have missed out certain components over here, and each and every these components can be coated with the dry film lubricants for the better performance, for the better purpose actually. So obviously, the why coating actually? What is the need of coating actually, right? While just few minutes back I just described about the benefits. Benefits could be ultra thin and lightweight. Nowadays, most of the vehicles are being utilized at very high speed applications. Okay, and obviously the ultra thin lightweight is going to be the keyword for most of the components. And while we doing the coating part of it, if suppose such kind of things are available for you, then probably it could be the best one. Excellent moisture, chemical and solvent barriers, excellent dielectric properties. Many times our components or the elements which are being used must be able to shock proof. They should be working whatever the way we have been talking about it, it should be shock proof. And the dielectric properties are very important for that. Superior thermal stability, excellent ultraviolet stability, excellent crevice and multi-layer penetration, minimal mass addition to delicate the components, and halogen-free options. So these are some of the benefits for the coating of these particular components. And we need to choose depending upon the area of exposure and the component where we are going to utilize. Based on that, the manufacturers have added certain additives into that, and which is what we call it as the coating applicant or the application which has been based on. We should be able to choose the right type of mechanism. The fluoropolymer coating is one of the very important meaning what we have been using. The fluoropolymer is the polymer that is based in the fluorocarbon and has a strong carbon fluoride bonds. Okay, and this fluoropolymer is an umbrella term, and it includes many other products with trade names like PTFE or the Teflon, the Excalibur, Algofarm, Xylan, Solef, and the Fluon. These are the different names. Of course, we as a probably users of this thing, we should be able to more concern about the application orientation of all these components, and let us concentrate on to that actually. So the lubrication of rubber material is the conventional lubrication and the non-conventional. Okay, the conventional lubrication usually is being done with the help of oils and the greases. Obviously, it is a while we are doing the oil coating, the very low friction values are possible to achieve over there and high wear protection. But at the same time, interaction with the rubber material is a major concern. Application on a single component is possible. I cannot be applying it to n number of components simultaneously, the oil or the grease. Every time I have to apply, choose one, apply it, and then put it for the application part of it. There is a fear of the contamination and the dust. This is the biggest problem actually. Even after application and then doing the assembly part of it, the possibility of getting it contamination is not at all eliminated. And aging process, they are quickly can create a problem for you, resulting the aging. Okay. Whereas when we go for the solid film lubrication coating, they are the dry and the touch proof. If you really touch it with your hand, you will not be able to get a feeling that there is some kind of lubrication available on the surface of that elastomer. So obviously the dry and touch proof, compatibility with the rubber material. This is very important. You can choose any type of rubber material. It can be utilized. That rubber is compatible with this PTFE coating or the dry film lubricants. Actually, PTFE is the brand name. I would be talking over the period of time about different types of coatings, what we have been using it over here. But the application wise, it is very easy, and the mass part application is possible for you. Long time storage of coated parts, it can withstand. I have seen in some of the application people have used 6 months to 1 year storage is very much possible. Especially, I will give the example during the COVID period. Some of the customers had a requirement of the PTFE coated components from us, and due to the market conditions, we were not able to deliver those. So we had kept those components after coating for the period of almost 1.5 year without any problem. And after the market opened, we deliver that. What I want to emphasize here, the longevity of the parts coated is a very high. Okay, and the long time storage of coated part is very much possible. Low friction values. The friction values could be ranging from 0.04 to less than that also actually. And limited use in dynamic application. Friends, here I would like to give one very emphasize on the limited use in the dynamic application in the absence of oil or the oil assisted applications. It means if somebody would ask me question, if I am going to use my oil seal or I'm going to use my cylinder seal for the pneumatic or the hydraulic application, can this be a dynamic? Yes, it is a dynamic application. And here we have observed that the life expectancy of a conventional oil cylinder seal as compared to the PTFE coated, we have got more than 60% life of the PTFE coated one. It means whenever the dynamic application in presence of oil, that time this is behaving very effectively and that is giving the better results. So one has to very specific about the definition of the dynamic application. So maybe sometimes the oil seals or the O-rings which are being used into the oil filled containers or oil filled applications, whether that can be dynamic, it is a dynamic, but it is again oil assisted. So the behavior of the PTFE coated or the dry film lubricated component is much better. So the reason why I'm just trying to explain little detail is that we should be able to define the dynamic application and a static application with reference to what. Yep. Then of course, now just to define in a defined manner, solid film lubricants are the dispersions of solid lubricants in solution of inorganic and organic resins in solvent. That's what we understood. Okay. And after the application of material, with the drying, it can create a dry film on the surface of it. So this definition is prompting us to go to the what are the characteristics, how it could be manufactured actually, right? So there are three major solid lubricants. One is the molybdenum disulfide, PTFE, and the graphite. You can see the three different colors over here. One is the completely black, that is a molybdenum disulfide, right? PTFE is a little whitish, and the graphite, which has got a little brownish, or though it is not properly distinct, but it is blackish and little white color into that. So it has got a low friction is achieved as a crystal structure share along the layer boundaries actually, and that's very important actually. Whereas for the PTFE, a low friction fluoride and particularly effective in the plastic lubrications actually. Molybdenum disulfide is again utilized, and it is very good for the where the high temperatures are very important actually. So looking into such kind of things, when I want to go for the 500 plus degree centigrade temperature, I can think of using the graphite. Now friends, somebody would ask me a question whether I would like, can I use directly the powder, graphite powder, or I can use the PTFE powder without any solvent and all as a dry film lubricant, because sometimes this is also essential actually. But in order to get it adhere to the surface, you require to add certain additional material that is called as the solvent or the water, and the additional binder also sometimes you will have to add it over there, right? So depending upon the mechanical properties and the mechanical requirements, one has to decide about it whether you would like to utilize the molybdenum disulfide or the graphite or the PTFE. The strength wise, if you really look into that, you will be able to find that more or less all the three have got a similar kind of behavior as far as the mechanical properties are concerned, like high load carrying capacity for the molybdenum disulfide, whereas the high temperature sustainability means I can sustain up to 500 to 600 degrees centigrade when I use the graphite. And the electroconductive behavior of graphite makes it suitable for the application as a graphite for where my requirements are very prone for the high temperature application, and electroconductivity applications are present for the coating. Whereas for the molybdenum disulfide, it has got a good adhesion behavior and it can be overcoated, but it is again the low friction values at a high pressure. But it cannot be, if I want to add any kind of pigment and make it a color kind of color prone or the color additive part of it, then probably I may not be able to use molybdenum disulfide. And then the only left out option is the PTFE. PTFE has got many more advantages compared to the molybdenum disulfide and the graphite, and that's one of the reasons people are more and more using PTFE as the dry film lubrication. I just mentioned that while making the composition of the dry film lubricants, the solid lubricants are mixed up with the binders, solvent, and the additives. Yes, these additives could be corrosion resistive or the protective elements, or the wetting elements, or the preservative, or the ultraviolet additives, and many more. So depending upon the type of application, one will be deciding what type of additive is required to be used over there. If you really look into this combination of that, then it is very easy for you to define whether your process can be more sustainable or not. Especially for the engine components or the metallic components, people are using the high load capacity or high load elements with the uh, organic solvents. Okay, and for the normal applications, people can usually go for the PTFE application with the water as a solvent part of it. Unlike any of your coating preparation or the coating application, the preparation of surface is also equally important. Okay, and if the surface is not properly prepared, then the solid film lubrication will not be applied in a uniform manner. Just to explain that, I have just given one example of a solid film lubricant on a phosphated metal, okay, and how it could be behaving or how it could be applying using as a dry film lubrication actually, right? The first figure you'll be able to see that a substrate is been coated with the 10 microns of solid film lubricants. Okay, now because of the metal which has been coated with the phosphated pre-treatment, okay, the pre-treatment has got the surface finishes a very important aspect of it. So the phosphated layer will be going and creating a little bit uniform surface over the substrate, and then when the color pigment or the binders are being applied onto the this phosphated component, it will try to form a layer. This layer could be ranging from 10 micron to 12 microns or 15 microns also. And now whenever the other mating component gets into the onto the surface of that, this material or the solid lubricants will get adhered to the mating surface, and then it will be forming a uniform layer. This has been explained to the third figure over here. And in terms of the uh, microscopic picture, it has been shown over here in this particular film. So it's very important to understand over here, whatever the structure of the dry film lubricants are concerned, we must be able to have the proper surface preparation and then apply the coating part of it. You must be able to remember this particular point here. Now, we talked about the elastomer seal or the O-rings. O-rings are typically EPDM, NBR, or FKM, or you name it. Different types of O-rings would be available, and they are been applying it depending upon the type of design. The compression will be ranging from 10 to 20%. Okay, and they are been manufactured with the 10 to this normally the injection molding or the compression molding. So in the process, when we have been using it as a Teflon coating or the PTFE coating or the dry film lubricants onto that, I'm not changing any of my mechanical properties. Only I'm adding the behavioral pattern for the wear resistance, behavioral pattern for the uniform load application. I'm improving the wear resistance. So that many times people do ask me that whether if I'm going to get any kind of change into the mechanical properties. No, whatever the base material properties would be available, those properties will remain same. Yes, it will improve upon the wear resistance. It will improve upon the chemical resistance. If the chemical resistant additives are added into that, that will improve upon, and obviously that will be the most important perspective. You should be able to keep it in mind. Now, just to explain furthermore the pros and cons of the different elastomers. Sometimes the people do ask me that whether I should be able to use the NBR material and get the FKM properties. The FKM is been utilized, which has good resistance to the heat and chemicals. And if I'm using the FKM as the especially engine mounting components and all, then can I use the NBR as the product and coat it with the PTFE and replace it with the FKM? The question could be very easy, simple actually, right? Because the FKM is costing very expensive. It could be costing about $50, whereas the NBR would be costing you around $10 or less than $10 actually. In the circumstances, whenever we have been talking about it, utilizing the basic parameters of that particular material and then translating that material in getting the better quality product, it is very much possible. But friends, one has to be very, very clear and keep it in mind that before taking such kind of decision, try to consult to your customers as well, because the customers would be the ultimately responsible for giving the appropriate response for this kind of situation to you. Now, as the positive and negative behavior pattern of the NBR, EPDM, and FKM has been, it is already everybody is known. I need not be repeating it just by reading and all, but this is very important that we should be able to choose the appropriate positive and negative perspective as of the O-rings or the material, rubber material, and then improve upon the priorities or the properties what we want to achieve with the help of this. And this is very much possible, friends. And lot many customers or lot many people are using this particular concept for improving the properties over here. So in general, for the solid film lubrications, general requirements are dry or no adhesion of the impurities, pre-coating of a large number of parts. It's very clear that nowadays my requirement are getting more and more. Maybe sometimes people are coming to the requirement of a few million pieces per month. And you can imagine if at all you want to apply each and every the oil or the grease, what kind of manpower you would be required. But instead of that, you can directly go for this dry film lubrication and do the coating part of it in the mass. And similarly, if I want to use the small diameter and the large diameter together, it could be very much possible to achieve it with the help of this dry film lubrication application. Storage of coated parts is, I did already explain to that actually, and running in improvements. Also, the optimization of our assembly is one of the important aspects I would like to give a thrust here actually. Everybody is talking about the Pokaika system and all, and most of the designs, the diameter of the O-ring will remain same with the cross section area a little bit here and there. You can imagine 8.5 millimeter diameter uh, 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 cross section area and 9 millimeter diameter. You'll not be able to make much of difference. And if I'm going to use the 35 millimeter of the both the together, then it is going to be furthermore problematic for me. Maybe once, twice I can read. But when I'm repeatedly using the same or similar kind of O-rings, then definitely I'm going to make mistake. And it could create a problem for the assembly part of it. So the solution there I can use one as a red and second as the green or second as the black. So I am very clear that green color or the red color O-ring has got a cross section of 8.5 millimeter and the black one has got a 9 millimeter. In short, just to explain it very critically and easily, that I would like to utilize the pigments or this dry film lubrication as the optimization purpose and by making the no mistakes by my operator, right? So it can reduce. There is one more aspect of it: the reduction of assembly forces, and thereby reduction into the assembly part of it. Timing required for the assembly is also reduced over there, and protection from damage during the assembly. Most of the problems, most of the difficulties people do come across that is during the assembly part of it, and this would be very much possible to reduce and minimize it over there. And of course, the lifetime protection, that is the wear protection. So these are the basic advantages, and I am going to utilize it these advantages for the same thing has been mentioned over here in a just to emphasize those points over here. And here is one example given for your ready reference, that the blue one, whatever the force which is required for assembling is about 250, and this component is without any kind of what you call the coated component. And the bottom one with the red one, it has got a better and effective behavior, and it is showing the minimum of 50 newtons of the force which is required for the assembly. And this has been already tested and it has been proven. Just to get you on a brief idea, this can get you the clarity while deciding about it going for the assembly forces and all. Now, while we do the assembly of a O-ring, the O-ring will not be going in a straight one go. It will be going in a slip stick, or it will be going in a slip manner actually. Okay, and that is called as the stick slip force. Usually, this is 100% required, and this is possible while doing the uncoated component. But if I use the coated O-ring, then you will be able to see that you are absolutely getting the smooth functioning, smooth insertion. It means the time required for the uncoated O-ring and time required for the coated O-ring, it is almost less than the 50% part of it actually over there. So this is the slipstick is another aspect of it, and due to which people are preferring to go for the PTFE coated O-rings and all. Obviously, increase of abrasion resistance. I just mentioned to you that one of my customer had used for the pneumatic application this PTFE coated, and the abrasion or the wear resistance, which has reduced to such an extent that life of that particular seal got extended by almost 40 to 60%. I do not want to claim that 40% or 60%. You yourself will be in a position to evaluate just by way of that. And there are different tests and the test methods which have been conveyed and defined by the various reference standards and all, which you can use it over there. Now, from the O-rings, I would like to go to the O-rings for the connectors, O-ring for the oil sensors. Now, you can imagine the behavior of the O-ring for the oil sensor and behavior for the connectors could be different. Because for the O-ring for the connectors, it should be able to be very, very different than the O-ring for the oil sensors. Because then now this is where I have been talking about it. The depending upon the type of application, you are going to choose the behavioral pattern and the requirements of additives into the system part of it. And that's where the important thing I would like to emphasize here, that you should be able to look into the MSDS of the material very critically, very effectively, and thereby you can think of choosing and selecting the appropriate type of additives into the system over there. O-rings for the phase sensor, O-ring for the thermostat, variety of things are there. Now here, this another example I'm giving the example to use in the sealing industry only, wherein one has to use it for the different applications of the exhaust systems and all. For the exhaust systems, you are again the behavior part of it will be separate. Air injection manifold or the air intake pipes. I was just talking to one of my customers from the brake application industries and all, and we were just deciding, okay, let us try to utilize it, the O-rings which are being used into the brake application, and the behavior of the rubber to the brake fluid, as you as a rubber O-ring manufacturers and all will be able to definitely understand the importance of this aspect of it, because the chemical resistance and the behavior part of it will be the very important aspect for the chosen rubber material. Either you have to go for a little expensive material, or you'll have to do the some kind of treatment for that. But if suppose we try to give the combination of that both, and then do the coating part of it with the dry film lubrication, then the behavior is definitely has improved, and the life expectancy have been improved by maybe 20-30% or maybe more, because many times this kind of figures are not available, but the results are very encouraging. So you should be able to decide about this kind of aspect while choosing the applications. The gearbox, the Daimler, or the variety of applications and all, you should be able to think of using it over there. The crankshaft or the camshaft, where this kind of seals are being used, these are another aspect of it, where if it is being coated, then the application becomes much easier for you, and also the life you are going to get is much more over there. Some of the plugs and the seal connectors, and now in the modern in the modern automotives, these are the safety features of the vehicles and all. So obviously, this automotive application, the locking mechanism and the seat belt, interior components, these are the variety of areas which can be coated by you in a very effective manner as and when required by the application requirements and all. Obviously, the application of the O-rings would be different for the automotive application, for the engineering application, similarly for the medical applications also. In the medical industries also, people are using the PTFE coated O-rings, and they have been giving the better results and encouraging the most of the manufacturers for going for the PTFE coated O-rings over there. General application or the general engineering applications are also, the cable connectors are there, sharp seals which are coated with the special coatings, the SBR parts are there. Then the variety of pharmaceutical applications where people are using the PTFE or the dry film lubrication into the industrial applications. So what is the coating process actually? Up till now, we did discuss about the applications and where my component is fitted. Probably somebody you would have found the, okay, this is my component. This is where I got a RFQ for the component. So what is the basic process actually? It is very clear. And simple, the pre-cleaning or the pre-treatment, application, drying, and the quality control. This is very simple. Looking into the process part of it, one has to be very clear that while dry film lubrication application, I just briefly described or mentioned about the cleaning or the pre-treatment. One has to be very clear that it has to be necessarily important for you to maintain the cleaning. The cleanliness, surface cleanliness is a relatively related term many times. I have seen many times you are doing the cleaning, you are doing the phosphating, and again handling it with the help of bare hands. That is not going to be useful actually, because the fingerprints or the fingertips, the marking, which are going to create a bond failure for you, which is going to create a problem for the dry film lubrication onto that substrate part of it. So you must be able to ensure the surface cleanliness by removing the dust, by removing the oil, by greases, fingerprints, and any other debris capable of winding up on the surfaces. I remember many times once you manufacture the rubber components, you are applying some different kinds of powders, actually, chemical powders. I do not remember name of that powder, but this powder is been used for so that you'll be able to not attract the moisture from the while you are just keeping those components into the system, or you are just keeping it open into the atmosphere. So this powder is also very harmful if at all you want to go for the PTFE coating or the dry film lubrication. It means you have to be very careful while applying the surface cleanliness. If the contamination is there, it is going to create a problem. The reduced contact between the adhesive and the substrate, and it is preventing a bond. It's simple. The bond failure is going to happen positively, and this could be cannot be predicted. The detactified adhesive, preventive, effective, wet out. I would be little describing this effective wet out and ineffective wet out also, just to get the terminology only. I do not. I'm very sure that you know the concept of the wet out and the this thing, but this concept should be able to be understood effectively. Actually, the effective wet out, when I say that the substrate is been coated with the adhesive by whenever the clean surface is there, and it allows for the maximum wet out and the surface contact potential. This is the important perspective. When I say that the maximum wet out and the surface contact potential, especially for the steels and all, this is very true. But for the engineering plastics or the O-rings or the rubber materials, the behavior would be different, because these are all called as the low surface energy elements. Okay, and they are prone to behave erratic or differently when it comes to a level of attracting the moisture or attracting the liquid. Okay, so we have I will be little talking more into this also once I finish this ineffective wet out. Now you can imagine if your o-ring or the substrate is being having some kind of dirt, what will happen? There is going to be the oil or the dust and all. So the effective area or the effective contact potential has been reduced to the minimum, and thereby it is going to create a problem, that is your bond failure. This bond failure could be happening quickly, immediately, or over the period of time. This cannot be predicted, because that will depend upon the behavioral pattern of this dust which has been connected with in sandwich in between the adhesive and the substrate. If it is going to be get switched off over the period of time, because that again uh, uh, enhances the behavioral pattern, and then it can create a problem for you, right? So we should be able to keep it in mind that we must be able to ensure the effective wet outs for any types of coating applications. I also just described about the lower surface energy part of it, right? So these low surface energy elements or the rubber components, which are, what do you mean by low surface energy? The best method is that put one drop of water onto the rubber element. If that rubber drop remains as it is over there without any dispersion, it means this material or this rubber has got less surface energy. If there is a bigger surface energy or greater surface energy, what will happen? That droplet which has been put onto the surface will spread out, and this spreading is nothing but your better surface energy. For the PTFE coating or the dry film lubrication, we require a better surface energy. Many times, most of the rubber component has got a lesser surface energy, right? Most of the engineering plastic, it has got a minimum or the zero, almost zero, tending towards zero as the surface energy. For such kind of application, one has to do a special treatment, and that special treatment is called as the where the gaseous or the plasma treatment. And this plasma treatment is a little expensive, but one has to go for that plasma treatment part of it over there. This is very important. Then again, I would go into that last. We haven't talked about the cleaning or the pre-treatment. Now the application, depending upon the volume, depending upon the type of geometry, depending upon the type of you can say the type of material also, right? We have got variety of applications. People do ask me whether can I apply with the help of brush. Yes, you can apply with the brush, but that will not be able to have the uniformity on the surface, because normally the dry film lubricants has got the limitations in terms of the process parameters. That is, you require to have the coating thickness ranging from 4 microns to 20 microns. If somebody would come and tell me that, okay boss, I'm using a rubber component, I want to have 25 microns of coating thickness, then I would be saying better way not to do the coating of 25 microns. This process will be a special or the separate process. Especially there are certain components which are coated beyond the 50 microns also. The best example is our food grade industry application, our tawa, the pans, frying pans, which are coated with the PTFE. It has got around 50 to 60 microns of the coating thickness. The behavior and again the process requirements are different for that, right? I deliberately try to explain the behavior part of it over there. Now, for coating a rubber and for coating a frying pan, you will require a different procedures over there, right? So it could be the immersion or the dipping coating technique, it could be the spraying technique, or it could be the brushing. Okay, but I would not be recommending to go for the brushing. The alternative method could be the dip spin, the dipping and the immersion and the dip spin. This is one of the method. But here the disadvantage is that you are not able to get a uniform coating onto the one particular area, and on other side you will be able to get the lumps from over there. Okay, so this is, but when one is a big size geometric components are there, people are also using it for that. I would be little more focusing here with reference to the spray drum coating application. The advantages for that is the mass parts can be coated simultaneously, adjustable coating thickness ranging from 4 microns to 20 microns over there. Homogeneous coating is achievable, suitable for the most of the SFL coatings, and colored O-ring coating is possible to achieve with the help of. Some of the samples which have been coated are shown in the form of a JPG over here actually. I would like to give a just brief a video clipping so that you'll be able to understand the parameters and the coating thickness which are being used into this application. The beauty of this machine is that it is a fully automatic. It can precisely tender the required coating material part of it over there. It could be possible to have the preheating, then the cyclic manner coating, and then drying part of it over there. So this is a very important aspect you should be able to remember into this kind of application. Whatever may be the process or whatever may be the application you are going to choose, these are the three basic parameters one has to keep it in mind. Another beauty of this is that I just mentioned that you can have the unequal or the small diameter or a big diameter or the uniform component which could be possible to coat simultaneously. Even it can accommodate the rubber as well as the metallic components together also if you have got a small requirement of the components and all. So these are some of the advantages which you have got with this drum coating machine. Now, what if I have got a geometric component or the flat components which are not circular, which are not even components actually, right? So for such kind of components, we have got we usually go for the XY axis robotic application or the deep spin applications as well actually, and both the systems are equally good or equally bad. Why it is good? It is possible to quote the predefined quantity in the sequential manner. Unlike your drum coating, it cannot accommodate big quantity. The restriction area is going to be your area of spray in while this XY axis machine. While the deep spin applications, the drum size of the or the rotator size will be the limiting factor, and also the components which are going to get connected with each other over there. So likewise, there are certain advantages and certain disadvantages. So you have to choose what advantages you would like to accept and appreciate for taking the component to the next level actually. So this is some example, the video clipping which is available for you. The component would be coming under the on the conveyor stage. Then the preheating has been already done on that, and the spraying application would be happening with reference to that. and then it would be done in the same place for the drying aspect of it. So one important thing you should be able to remember, the coating thickness would be going one after the other. Means the first coating you will be able to achieve 4 microns. Then with the maybe next to 1 or 2 cycles part of it, you will be giving it for the next 4 ampere, 4 micron or 8 micron, depending upon the type of gun or the components which you have been using it over there, right? So just before I say thank you, one important aspect I want to give it to you is that the basic parameters which you should be able to keep it in mind for the spray application is the gun diameter or the nozzle diameter, then the flow requirement for that, and the time. So these are the 3 major parameters which determines your coating thickness. Okay, and there is a clear-cut mathematical correlation available with reference to this, and which can be made it possible for you to define number of throws or number of coatings one has to use it into the machine part of it. So with this, uh, I think you have understood a little bit about it. The people are using this as a technological advantage and going into the next level and encouraging themselves to be exporters of this kind of components to variety of countries. Worldwide, this is the much needed requirement or a much needed technology people have been utilizing. So it's up to you whether you are going to utilize it and for your benefits and try to take the advantage of it. You please decide and choose. Thank you very much. Any questions for you? You can very well ask. Bye.